Hi, my name is MOHAMMAD SAFWAN bin BAKKERI, and this is a presentation of nuclear power generation by Group 3. What is nuclear power generation? Nuclear power generation is a process of generating electricity by using the energy that comes from nuclear fission. In this process, atoms are split and the heat released is used to produce steam. The steam then drives a turbine which generates electricity. One of the major benefits of nuclear power is that it provides continuous and stable electricity with a high energy output. This makes it suitable for supplying a consistent amount of electricity over a long period of time. Now, let us look at why nuclear power is important. First, it can produce a large amount of electricity while releasing very low levels of greenhouse gases. This makes it much cleaner for the environment compared to fossil fuel-based power generation. Second, it helps reduce our dependence on fossil fuels and supports long-term energy sustainability. From engineering point of view, electrical engineers play a key role in the development of power generation, control system, safety system, and grid integration of nuclear energy. Nuclear power is a highly efficient and reliable source of energy that supports both environmental and energy goals.
Hi, my name is SYAMEEL and I'll be explaining the basic construction of a nuclear power reactor. Okay, so a nuclear power reactor can be divided into two sections, which are the reactor core as well as the turbine hall. So fuel elements, moderator, and also the control rods are the components that make up a core reactor. So firstly, the fuel element acts as the source of energy in the nuclear reactor. It usually comes in the form of thin rods where several uranium dioxide pellets are slotted together, and they are encased in a metal rods that are usually of about 1 centimeter in diameter. In a nuclear reactor, the fuel rods are immersed in water, which is known as the moderator. The moderator slows down the fast-moving neutrons produced during the nuclear fission to allow for a higher tendency of the neutrons to collide with the uranium atoms. The last component in a reactor core is a control rod. Control rods are made out of neutron-absorbing materials like boron or cadmium. By adjusting the position of the control rods moving up and down in the reactor core, the rate of the nuclear reaction can be controlled or completely shut down by absorbing the excess or unwanted neutrons. Moving on to the second section, which is the turbine hall. So the steam generated by heating water using the nuclear energy will be transferred to a turbine, which will then spin the generator connected to the turbine via a shaft. So the kinetic energy from the spinning turbine is then transferred to a generator. So a generator is an electromagnetic device that translates mechanical energy into electrical energy that is then supplied to the power grid for the use of end users. The next component in a nuclear power reactor is a condenser. So a condenser is essentially a heat exchanger that cools the steam back into water after it has passed through the turbine. So it ensures that the water can be reused back in the reactor core. This is achieved by circulating cooler water from an external source such as the river or the cooling tower. The final component in a nuclear power reactor is a cooling tower. So by definition, a cooling tower is a large structure used for cooling the water used in the condenser. So it removes excess heat from the water by allowing it to evaporate into the atmosphere or exchange heat with the ascending airflow. So water is collected in a basin at the bottom of the cooling tower, and the water returns to the condenser to be used again by the reactor core.
Let's begin by understanding the principle of nuclear fission. Nuclear fission occurs when a heavy nucleus such as uranium-235 absorbs a neutron. This absorption causes the nucleus to become unstable and split into two smaller nuclei, known as daughter nuclei. Along with these fragments, a large amount of energy and more neutrons are released. These newly released neutrons can go on to cause further fission reactions in nearby nuclei. resulting in what's called a chain reaction. The typical reaction is uranium-235 plus 1 neutron produces krypton-92, barium-141 and 3 more neutrons and more energy. This is the basic mechanism behind how nuclear reactors operate. Now, how does this process work inside a nuclear reactor? First, a few rods containing uranium undergo fission in the reactor core, generating heat. Second, control rods are inserted to absorb excess neutrons and help regulate the rate of the reaction. Then a coolant flows through the core, absorbing the heat generated from fission. Then this heated coolant transfers energy to a steam generator, which boils water to produce steam. Then the steam turns into a turbine, which is connected to a generator that produces electricity. This entire process is a controlled environment for sustaining a continuous and safe chain reaction to generate power. Finally, let's compare nuclear fission and nuclear fusion. On the left, fission involves the splitting of heavy atoms like uranium-235. It releases a large amount of energy and is a process currently used in power plants because it's proven, controllable and feasible with today's technology. On the right, fusion is the combining of like atoms like hydrogen isotopes. It naturally occurs in stars like our Sun and releases even more energy than fusion. However, fusion requires extreme temperature and pressure, making it still experimental and not yet practical for power generation on Earth. So while fusion has great potential for the future, fusion remains the primary method used today for nuclear power.
Next, I am going to show you some pictures about the nuclear power generation. The first picture is nuclear power plant overview. It is consisting of reactor, tubing, steam generator, and cooling tower. The second picture is nuclear reactor core containing uranium-235 and control rocks made of neutron-absorbing materials like boron. The control rocks regulate the fission reaction and prevent overheating. The third picture is cooling tower that helps to remove excess heat from the system using water cooling loops. The fourth picture is turbine and generator system that convert the mechanical energy into electrical energy. The last picture is containment structure that prevents the escape of radioactive materials in case of an accident. Then I will go through some examples of nuclear power generation site. The first one is the Kashiwazaki Kariwa nuclear power plant in Japan. It's the world's largest nuclear power plant with a net capacity of 7,965 MW. It's located in Niigata Prefecture, about 220 km northwest of Tokyo. The plant consists of 7 boiling water reactors, with the first 5 having a gross capacity of 1,100 MW each, and the last 2 having a capacity of 1,356 MW each. The second one is the Hano nuclear power plant in South Korea. It is the largest South Korean nuclear power plant and the second largest globally. The plant currently has a net capacity of 7,338 MW, made up of 6 Hano reactors. Each of these reactors varies from 966 MW to 999 MW. The last one is the Bruce Nuclear Generating Station in Canada. It is owned by Ontario Power Generation and operated by Bruce Power. The plant has a net capacity of 6,358 MW. It consists of 8 pressurized heavy water reactors with net capacities varying from 769 MW to 817 MW. These are the references we use in this assignment. Next, there are 4 members in our group including me. My name is Kevin Xia Shaoxian, the group leader. The others are Michael ENOP, ALIF SYAMEEL, and AIMAN SAFWAN. I think that's all from our group. Thank you.